Hello everyone. In this video we are going to talk about the Prusa Slicer software, and there are several items that we need to work on, a bunch of items that I need to discuss with you how to use them properly to create an efficient G-code for your 3D printer. So let's get started. So this is the Prusa Slicer Software 2.2.0, and when you first install this software, one of the things that you do is called the configuration wizard, and that is really to tell the Slicer software what printer is it that you are using, what filament, and just give it some general knowledge so it can do the setup of the filaments, the infill, the layer heights, and everything properly for your application. If you did it initially and you did it right, you're good. Otherwise, you can always go back and revisit and fix it. So you go to configuration and bring up the configuration wizard. And here you tell it whether it is an fused deposition modeling, or you might call it FFF also instead of FDM, right? Or it is the SLA printer. So you choose the type of printer that you have, right? So for me, for example, it could be Prusa Original i3 MK3S and MK3S Plus, right? Or just the very original one, or then the mini, right? So there are MK2.5 family. These are the older versions, right? Most of the people these days have this one or the mini, right? Or mini is this one actually, or this other one, which is MMU2, depending on the type of the multi-head that you have. So MMU is the multi-material unit. And this type of printer can use several spools at the same time with different colors. And what this one can do, as you can see, it can give you a part with several colors or several material. So you have to add this multi-material unit on the top of your printer, and it gives you further capabilities. If you want to use one spool at each time, right, then use this original version. And this head is not really expensive. It's just like $200-300 bucks. The printer itself is about $800. The mini is cheaper, but it doesn't have as big of a print size and some other capabilities that this one does. So this is just a configuration. You choose it, and once you set up your print, you go to next. If you have SLA, you can add it. If not, then if there is any other vendor that is supported, you can say. Otherwise, you can go ahead and tell it what kind of plastic is it that you are using, right? Right, ABS, PLA, who is the vendor, right, and so on. And then it creates a print profile for those plastics. So let's say if you say generic PLA, then it adds a print profile for generic PLA, right? And by print profile, I mean like the speed of the movement for the motors for the hot end, the temperature, and some other parameters that you need to properly print PLA plastic. I'll show you those parameters, right? So it generates a profile. It has those profiles, many of them. And when you check them, then they will be accessible for you to select later on. And then once you're all good, then you say finish. And as I said, this allows you, when you come here to the print setting and you say, hey, my filament is generic PLA or any other one of those plastics that I chose, when you choose PLA, then all of these parameters under the filament setting, right? The temperature, the estimate of the cost, the spool, the color, you can change that for the visualization of the printed slice part, the cooling stuff, right? Then you have all sorts of other parameters, as I said, right? For the print setting, as I said, the speeds, right? The temperature, all of these are coming from the profile of that specific plastic and the specific layer height that you choose. So that's the first thing you need to set up. Once you're good, now you're ready to import your model. So you can either go to File, Import, and bring it, or you can just click on this plus here. Then go ahead and let's say here I can add something from my models and bring the model here. If you bring the model and then the model is added, the STL is added on this right window, if you see this exclamation mark inside the triangle, that means there are some more errors that the printer slicer has to fix. Okay, so if you see that, do not go to slicing or anything. Do a left click on this exclamation mark and let the NetFab services repair the problematic edges, areas, like could be like non-manifold edges, vertices, or so on, and wait until it says model repair successfully. Then that guy goes away. Now it is ready if you want to do slice or anything. So don't rush to slice it if you see that exclamation mark. That's the first thing. Now, sometimes the part that you bring is like an assembly. Okay, they exported the entire assembly into one single STL file, but here the software allows you to break it down into the individual components. For example, if I go ahead and add another model, let's see, this one. Okay, so this one is an assembly really. So this is the eagle, all of those letters are added to it, and then we have the key ring. So it is really an assembly, but I saved all of it as a single STL file. It doesn't have any problem. So now with this one selected, first of all, let me scale it down a little bit, and that's one of the things you can do is scale it down, because if you don't, then it tells you here. It says the object is outside the print area. Means the size of it is more than what Prusa can print, right? And you clearly can see that the original Prusa, in the Y direction it goes 20 centimeters or about 8 inches. In the X direction it goes 25 centimeters or about 10 inches. And in the Z direction or height also, it is almost 8 inches. The actual, if you look at the website, it says it is 9.84 by 8.3 by 8.3. Okay, so if you want, I can just add it for you here, right? The print volume, when it talks about here, say print volume of Prusa original i3mk3s, right, is 9.84 inches by 8.3 inches by 8.3 inches. Okay, so this is the max that you can print with this printer. Do not expect bigger than that. If the part is bigger than that, you have to either scale it down, or if you want to keep the original size, you have to break it into parts and use joints, design joints for it. So keep that in mind about the maximum print size that you can have. I would say it's almost like 10 by 8 by 8, almost. So clearly this one is bigger than that. So in this case, I don't want to keep the original size. So I just choose the model, go to scale factor, and let's say scale it down to, like, say 75%. Right? And then this is another thing we can do. We can lay it flat on the bed. So now you see it is definitely fit the print bed. Now what I can do, I choose this guy and then break it down into objects. And if you do that, now you see it was one object. Now there are lots of objects here. So one of them is, if you look, one of them is this guy, the eagle. One of them is the keychain, and then the rest of it is all of these letters, right? So if you don't want them, let's say, you can get rid of them, right? Or you can print them individually and then glue them. But you clearly see that here I have two objects, and when you click on arrange the print bed, if all the parts do not fit, then it leaves one of them behind like this, and it tells you that there is an object outside the print area. Okay, so that's not a good thing unless you want to print it in two separate prints or so. But clearly you see I could break my entire assembly into individual components, and then now let's say I want to first print the eagle, so I bring the eagle here and I print it, and then next time I print the ring and then I assemble. So you can break an assembly into components. Good. Let's move on. So the other thing, as you clearly saw, is the part manipulation. What does that mean? It means, let's say here I have this eagle and I want to print it. So the manipulations are here on the left side, and you can numerically enter the numbers here on this right window. If you click on the part, so the part when it's not selected is orange, when you select it goes green. If you see on the right side window, it shows you the current size. Okay, and these dimensions are all in millimeters. So it's 171 by 124 mil in the X and Y direction, and in the Z is 15 millimeter. Right? You can see that. And it has 2700 facets, right? Because it's an STL file. So the surface of it is made of a bunch of triangles. How many? 2700. The scale factor is 75. There is no rotation, and that's the position of the centroid of the object. So now what if I want to move this part? So if you just want to move it, just left click on the part and drag it. Right, and you can position it anywhere you want, or you can just directly type the number, right? So if you want to move it along X direction back a little bit, you go from 131 something to 120, right? Move it a little bit forward, so let's say 110, and then in the Z direction, you don't really want to do it because it's gonna lift it off the surface of the bed, so you leave it as is. Right? Or if I want to rotate it, so then you can rotate it about the x-axis, the y-axis, and the z-axis. So you can say, hey, rotate negative 90 degrees and make it like this. You can do both of those things as the position and orientation also through here. So you can use this move command and move it. And the good thing with these guys is they have perfect control to move it along X, Y, or Z. The same thing with rotation. You can grab any of these, basically 3 double arrows, and you can rotate it in any way that you want. And it shows you the amount of rotation, but you're controlling it with your mouse. It's better always to exactly control the numbers from here and type the numbers. The other thing you have is the scaling. As I said, you can do the scaling from typing the number here, and or you can do it using the scale and grab any of these squares and scale it. But before I do scaling right now, since it is not really positioned properly, and if I want to print it, it's gonna need a ton of support below it. So one of the best thing is if there is a flat surface of the part, and that makes that print easier. If you print it on that flat, it reduces the amount of support. Then click on the part, click on this guy here, which is placing a face on the surface of the print bed. Click on here, and then it gives you all of the surfaces that it can lay those flat on the print bed. And here I choose this bottom surface and lay it flat on the bed, right? If you want to rotate your view, right, you see here I'm always rotating my view. All you need to do is to hold down the left mouse key and just move, right? So you can hold the left mouse key button and move. If you use the scroll of the mouse, you can zoom in and zoom out. And if you hold down the scroll and drag, then you can do the pan. Okay, so you can move the print bed using holding down the scroll button. Also, if you want specific angles of the view, you can use numbers 0, 1, 2, 3, and so on. You can see them under view. So if you want to see it from the top, use number 1 from your keyboard. If you want ISO, you put it at number 0, right? So let's say here, I change the orientation to something like this. And then I want to put it back to ISO view. I just click on 0 from the keyboard. Then it puts it back to the proper orientation, right? So here I have made this part to lay flat, and let's say that's the angle that I want, but I want to rescale it. As I said, I can enter the numbers here, or I can click on the scale, and now I can what? I can scale it. The good thing with this scaling is it's not going to be uniform in all directions. So if you look at these numbers here, the Z scaling does not change. Only X and Y do. Okay, but if you enter a number here, right? So then it is going to try to apply that same number to all of the dimensions. So tries to basically scale them uniformly, right? So let's say here, let me bring one of these, maybe the alphabet, right? So as I said, if I scale down everything with the same number, look, all 300s become 75, right? But if I don't want the scaling to be uniform, then I click here, click on the scaling, and then I can scale in one specific direction, right? So that's the good thing about this scaling, that you can do it non-uniformly. Okay, so that's about those important manipulations. Resize, rotate, pan, place, face. Another thing you can do is if you want several replicate of something, you can do that. So let's say here, if I bring a small part, let's see, or I can make it small, but let's say here. So I have this whistle and I want to print this, but I want more than one. So first fix the errors in it. And if you want to do it, it's not a good idea to keep clicking on this and bring another one, another one. Once it's fixed like this, all you need to do is what? Do a copy and paste, or the better one is to click on this plus. And it just add one more, one more, one more. So let's say I have 6 instances and I want to print them. Definitely you don't want to print like this because the parts now have overlap. So the next thing you want to do is to arrange the print bed so that the distance between these parts is an optimum distance. If they are too close, like this, that they even have overlap, you definitely get a bad print. They are all going to be welded together, right? If you make them separated, yet the distances are not so big, there is a chance that your print bed will knock one of them out when trying to move between them. And if you make them to be far away from each other, then the print time is going to be long. So the best thing to do is to click on this arrange bed and let the software decide the optimum distance between them and the optimum arrangement. Okay, I always recommend you let this arrangement do it. Sometimes this arrangement might not do the best thing because it always tries to go uniform. Sometimes if you want to squeeze more on the print bed, you can, let's say here, I bring another one, and then you can do the manual arrangements, okay? But again, this one most of the time does a lot better job than you do to minimize the print time and minimize the chance of collision between the print head and the parts that are already on the bed being printed. If you don't want any of them, just click and delete, or do a negative right to get rid of them, or just click here and click on the trash can and delete that. Right now, if you do delete, you see clearly the whole thing, the whole print bed will be deleted. Okay, so you have to make sure you see it says all objects. If you want a specific one, click on it and use delete from the keyboard. Okay, so this is about the print bed arrangement. And now that you got something ready to print, now it is time to talk about what? about the infill, shells, layer height, and so on. So let's say here I bring in a part and I want to let's bring back that snowman and fix it. And now you want to decide on how to print it. In my previous video, I have explained those important parameters, infill, layers, support, and so on. But there is a little bit more to them when you are doing it in the software. So this time, I'm going to show you how to set up all of those important print parameters. Okay, so regarding the layer height or layer thickness, that's determined up here. You can go anywhere from 0.05 ultra detail, which is like the finest layer, the thinnest layer, to 0.3, which is draft. And then for several of these layers, especially 0.15 and 0.2, you have two options. You can have it to have the same layer thickness, but print a little bit slower and get you a better quality surface, or go fast and although you have the same layer thickness, but you still might get a little bit rougher surface quality because it is moving too fast. Okay, so there are two things that matter in a print quality. The major one is really the layer thickness, but the speed does matter. If you try to go fast, there is always a good chance that you do some failure somewhere. You don't lay enough plastic, you lay more than enough, you put less than enough, right? It's always better to let printer not rush the job and get you a better surface quality. But if you are short on the time, then you can choose the option of, let's say, 0.15 speed versus 0.15 quality, or the same for 0.2. So let's say I'm good with 0.2 quality, which is the default of Prusa Slicer. Then what? You need to determine the plastic. So you choose your filament from the list of the material that you have already selected in Configuration Wizard. And if for any reason you have a plastic now that is not in those list, you can always go down and say add and remove filament. Okay, then if it recognizes the vendor or the plastic, it tries to get you the print profile for that specific filament. So here I'm using a generic PLA, not Prusa PLA, and I go with that. Your printer is already set. Now it's time to go with support and infill. I told you support is the plastic for overhangs. If you say none and slice, then you will get no support for overhangs whatsoever, and that will lead to failure of many overhangs, especially if their angle is more than some threshold like 45 degrees, or here 55 degrees, the transition angle. So you see, there is no support, and that definitely will cause to a failure on the nose, on this kind of scarf, on the head gear, and so on. So it's always a good idea, if you have time and you don't mind a little bit adding a little bit more plastic, I would always use everywhere if possible. And if the cleaning of that plastic is not a super hard job, it's always better to use everywhere for the support, right? So you see, everywhere it adds this low density green plastic as the support, which you can easily peel off or break using a line nose plier. The other thing is, sometimes you only want to generate the support for the areas that the bottom of the support comes into direct contact with the print bed. So any support that the bottom of which does not come onto contact with the print bed, you can eliminate those. So let's say here, the top part of it, I'm okay, I don't want that area, I just want this area. Then I change it from everywhere to what? Support on build plate only. And then you only see the bottom parts being supported, as you can see here. And then there are a couple of other things that are important. One of them is called a support blocker. The other one is called a support enforcer. So what are these? These are areas that you want to have a support, although naturally software does not add it, or you want to eliminate a support when this software thinks it should add. So let's say here I want to do the opposite of what I have right now. Instead of generating the support that comes into contact with the build plate, I only want the area that is on the top, and I want to eliminate this. There is no option for that. That generates it on the top, but not on the bottom when it comes into contact with the build plate. Unless I do what? I go back here, I go back to the regular view, right, 3D view, and by the way, you know these two on the bottom, this one is to go back to 3D view, this is to go back to the sliced view, right, these two layers. So if I go here, and then I right click, and then I say what? Add a support enforcer or add a support blocker. Then it allows me to create a 3D shape, and then anywhere in that 3D shape that 3D shape overlaps with your model, you can avoid the support or you can force the support. So let's say here I go and say add a support blocker, the shape of a box, and it gives me this box, and then I can click on this box, click on the resize, and then resize it and relocate it to get over the area that I want not to have any support. Okay, so I bring it up like this. Now that whole area that has overlap with this box, that is not going to have any support, even though I say everywhere, look. When it does that, it's not going to do that area. And you can clearly see the result, right? Only generates the support for the top part, not that area that I blocked. So you clearly can see. Or maybe I do what? I right click and say add a support enforcer. And again, I say a box. And maybe the only area that I'm interested in adding a support is under, let's say, the nose here. Okay, so I make this longer and make sure it covers the nose area like this. And now, instead of everywhere or none or anything, I say only for what? For support enforcers. So if there is a support enforcer like this block somewhere, generate support there, otherwise no support, right? So I say change it to for support enforcers only. And now you clearly see that's the only area that I believe it needs a support. It just generated over there, nowhere else. So hopefully that is clear. The type of supports, none everywhere on the build plate only, and for support enforcers, right? And then the meaning of the support enforcer and support blocker. Good. So once we know about the support, and one other type of support, as you know, is a raft. So if you go to print setting and go under the support material, raft, remember, is the plastic printed beneath the object. So here you can change the number of layers of raft that goes below the object before it's being printed. By default, a slicer of Prusa does not add any layers, but here you can what? Go ahead and change it, right? So here, 3 layers for the raft. We go back, and now if we re-slice, you're going to see 3 layers of support below the part, right? As I said, this is what you can clearly see, right? 3 layers. And that's the meaning of raft. And raft is used, as I said, to my previous video to stabilize the parts that are tall and have a small surface contact area at the bottom, and helps them to be stabilized and stick to the print bed better. So that's about support in Prusa Slicer. And layer height, now we get to infill. And here you can specify the percentage of infill, right? So you can say printed with, right now I guess it was printed with 15% infill. So if you go down, just grab these layers down, right? You see this pattern that you see here? This infill is called gyroid, and the intensity or the percentage is 15%. Now I can change that and go to, let's say, go here to infill and change it to from gyroid to rectilinear, which, as I told you in previous video, it is giving you a little bit stronger part, and it's giving you much faster print time. If you go back and look here, right, if I reprinted with 15% rectilinear, you see that it's 9 hours 29 minutes, right? And you can see the rectilinear pattern here. Correct. You can clearly see this pattern. That's with 15%. Now if I go back and change it back under print setting to gyroid again, you can see that 9.5 hours will be converted to more time print, right? So although it's the default of Prusa, I absolutely do not recommend using gyroid. And I'm not sure why they set it as default, but definitely not a good infill. You see it's now 10 hours 20 minutes, so you're losing 50 minutes on this simple part. Okay, so definitely change it to rectilinear, okay, or the grid pattern, and the intensity of it, you can go as low as 0%, which literally mean do not print anything inside, make it completely hollow. Just have a few solid shell layers on the perimeter of the object, so you see clearly it's completely empty. And that's 7 hours print time. And now if you say completely solid, now you see how much your print time is going to go up. Of course, you're going to get much stronger, heavier parts, but at the expense of using more filament and using more time of the print, right? So you clearly see here, there we go. It's 18 hours, 7 hours working versus 18 hours, and 293 grams of plastic versus, I guess it was, let me double check it. So you see, right, 72 grams. So you see how many more times you have to use plastic and how much more time you have to put to print it completely solid versus completely hollow, right? And ideally, completely solid is really for cases that the part is functional and you want it as strong as possible. Completely hollow is when it's pure decorative and you're sure that it doesn't fall from your hands. And if you want to guarantee it doesn't break, then definitely you need to bump up the number of layers or shells. Because with 2-3 layers, that is the default here. And with no infill, you have a very, very, very good chance of it falling from your hand and breaking. Okay, so the default is somewhere like 20-15%. So that's one thing, and then you go to print setting, and now you can go to layers. And that's the next topic is layers, the solid layers or shells. And Prusa typically give you different number of shells on different directions. So the bottom of it, like 4 layers, the top of it is 5 layers, the perimeter is 2 layers. Okay, that's what it suggests, but you don't have to stick to those. So let's say I want 4 layers all around the object. Good. I want the perimeter, top and bottom, all be 4 layers. And then I want the infill to be, let's say, 20% rectilinear, and then of course, adding more shells which you can see here in yellow color, will add a little bit to the printing time, but definitely makes your part significantly stronger. Okay, so I personally never suggest printing anything below 3 or 4 shells, right? And again, you can see the different type of plastic is color coded here, as you can see on the left side differently. So if it's on the perimeter, you can see it is shown with yellow. External, the very last layer of perimeter is orange. If it's a top solid infill, right? So it's the top, then it is green, right? And for example, if it's a skirt, which you can see down here at the very bottom, this few layers for the basically to make sure that the flow is right, priming the nozzle, that is in brown, right? And so on and so forth. Internal infill, as you clearly see, it is kind of dark red, maroon, you might say, which you can see here, right? And then you have the bridge infill, correct, like this. Actually, this is solid infill, but you might also have bridge infill. If you do, then it shows it with this color that you can see. It's kind of, you might call it, I don't know, purple or close to purple. So green, light green is for support material and so on. The place that the green material touches the object, the interface, is going to be dark green. So that's the good thing. It color codes everything for you in Prusa. And again, you can see on this slider on the right side, it shows you all of the number of layers. So you start at layer 1 and you go all the way up to 736 layers, right? And you've multiplied 736 by 0.2. That should be the height of the object, which is like 146.71. So here, let me show you that. If I go here and go back to this mode, 736 and then multiplied by 0.2. So the height is 147.2 that you will get, but the actual height is 146.71. Okay, so you might say, why are these two quite a bit different? And I expect something close to 0.2 of difference, no more. And the answer is, well, you have now rafts, right? Remember, you have activated rafts. So we have 3 layers or 0.6 millimeter thickness already for raft. So you need to get rid of them if you want the height to be comparable. So now you have 734 layers, right? And now hopefully you're getting closer. Right? So now you're getting closer. You see it's 146.8, the part is 146.71. And since 146.71 is not an integer multiple of 0.2, so the printer has to either go with 146.6 or 0.8. And since this number is closer to 0.8, it's rounding it to 0.8 as I showed you. Okay, so you clearly can see the Z for each layer and the layer number, right, as you go up and down here on this slider. Okay, one other thing you can do is, you see right now you have the infill percentage to be the same, 20% all over the object. Sometimes you might want to reinforce some area and use a different infill percentage in that area compared to everywhere else. So you want to customize or a local infill. Can you do that? And the answer is yes. So you right click on the object and say add a modifier and then choose the shape, let's say a box. And then you can resize this. Say something like this, and then try to move it up or down. So here, I'm going to move it up a little bit. something like that, or a little bit less to get it in the neck area, something like that. You move it also in the X direction, right? So close, let me put it at 10 maybe, yes. And then definitely go down further in Z, something like that, a little bit maybe more still. And then you move it back in the Y direction. So if you make it like 0, right, it is kind of good. Still want to bring it down a little bit further, maybe 0 now. There we go. So now you see it's completely around the neck area, right? That's exactly the area I want around the neck where there is a stress concentration. And I say, well, that area, I want the infill of it to be different, because for this area, I want it to be 20%, correct? But for this area, if I go ahead here and look at this, and click on the gear and then go to infill, so that area, I add an infill to it. That's a separate infill, and for that area, I wanted maybe what, 80%. So now everywhere else is 20%, that one is 80%, so let's go ahead and slice. Then you can see the difference. So this modifier is actually a very good thing. And if you saw, it's not just the infill that you can locally modify, you can do a bunch more. So let's take a look here, what's going to happen. So if you go down, you see this percentage, right? That's 20% infill. But when I get close to the neck, which is this area, as you can see, look. You can see it's almost close to solid, because for that small area, 80% is almost literally means solid. So you see here, the infill is almost like layer touching the other layer. But if I go up, you see, now you can clearly see the density is what? Maybe looking at it from the top is better. Now you see the squares, you can see the squares, and then look here. They get what? They get almost close to complete solid, because again, it's 80%. So you clearly see the local modification. And as I said, it's not just the infill that you can modify in that area. You can click on this gear, and then you can even change the number of layers over there too, right? Or you can add more settings. You can change the speed of the print in that area, the extrusion width in that area, advance, and so on. So maybe if I want that area, instead of 4 layers, I want it to be maybe printed with 6 layers on the perimeter, top and bottom. Again, now I also have changed the layer in that neck area. So you can locally reinforce your part, and that makes a big difference in the 3D printed objects. So let me show you this, and then we move on to the next topic. So now you see here, you clearly see that I have 4 shells, right? Then let's go down to the neck area. 4, 4, 4, there we go. You see, now you have these yellow layers, they are 6. Okay, so that's the local modifier, which is an extremely good thing. And whenever you don't want it, all you need is to click on it and delete from the keyboard. Okay, what else? So we have seen the raft. We by default, Prusa always does a skirt around the object, right? That you can clearly see. Let me make this a little bit smaller, so not every time we have to wait a lot for it to slice. So whenever it slice, always you have the skirt around it, because that's to make sure that the hot end is clean and the flow of it is perfect. But if you want, you can add a brim, and brim means connect that skirt all the way to the bottom of the object. And brim helps really not only the outer layers of it or the skirts, but it also helps with attachment of the part to the bed, okay, and a little bit of stability. So it's not going to go under the part like raft did, but it is somewhere between a skirt and what? Somewhere between a skirt and a raft. Okay, so if you want a brim, all you need is to check the option for brim. Okay, so that's about brim, raft, and skirt. Then we have the temperature of the hot end, the flow rate, the fan speed. So let's talk about them as well, and they are under the print setting. So here, if you looked, when we were under the print setting, we could change, here you can see the layer, that's the layer height. Even the height of the first layer in this software you can tune or change separately from the rest of the layers if you want. Right, and the shells and everything. So these are all there, but as I said, we are after what? We are after the speed. So these are the speed for different motions. You can see how fast, how many millimeters per second it moves to print the perimeter, to print the infill, to print the bridges, to fill the gaps, and so on. The travel speed, which is for areas that it's not laying down any plastic, it's just moving from point to point to get to the next point so it can lay down plastic, right? That is travel speed, which is much faster than the rest of it, because it does not need to keep the tension in the plastic, right? You can have accelerations, which is if you want to go from one speed to another speed, how fast you want to change the speed, right? The acceleration rates. So these are the print speeds, and my suggestion is do not change them unless you really know what you're doing, okay? But you can change all of the print speeds and accelerations here. And then, as I said, we have to talk about the flow rate and the temperature, right? So to look at the temperature, you go under filament setting, and you can see this is the temperature area, right? So this is the bed temperature on the bottom, the hot end or the extruder temperature on the top. And if these are for generic PLA based on the data that Prusa has, but if you buy a PLA filament and the vendor says no, print the use the hot end temperature of 220 and maybe a bed of 55 or something, you can come here and customize that. Here you can just change the color of the preview of that PLA, right? But it's not really going to affect anything about the G code. It's just the graphics, right? So if I make it red when I go back here, it is going to show the part in red. It's just pure graphics. So I have shown you the print speed. I have shown you the temperature, as I said. And now the last thing I wanted to mention is, and under cooling, I guess I mentioned that if you go look at the cooling, here you can see the fan speed, right? How fast you want the fans to spin to cool down the hot end. Then you can change the speed of the fans here. Let me show you a few other things very fast. So if you buy, let's say, a print bed, and the print bed is not the original print bed of Prusa, you can come here under printer setting, under general, and then go here and change the size or the shape of the print bed, right? That's one of the things that could be useful to you. Then if you go under machine limits, this is where the machine is supposed to stop and start in x-axis, y-axis, z, and e-axis. And again, I absolutely do not recommend you change them. unless you have a valid reason to make them a little bit smaller than what they really are, and you don't want your stepper motors to move your components from the beginning to the end of the potential basically machine size, right? You just want to limit the area that your printed and the bed is moving. Then you can limit the machine size and limits, but again, I don't recommend. Under extruder, you see the nozzle diameter and something, you can modify stuff. This is the area that I mentioned in one of my previous videos, retraction. I said this is what you need to avoid the stringing. This is what you need to avoid those here. That's the thing that I mentioned for you in one of my videos. If you want to avoid laying down plastic somewhere, either on the solid bed or up in the air or anything, plastic coming out when you're just doing the travel motion and you're not supposed to lay down any plastic, you want to avoid this, you need to have retraction. And retraction means pull back the filament into the hot end when you are just traveling to the next point to lay down plastic. And here you see this is the length that the plastic is pulled back in, right? If you see you still have the stringing problem, you can come back here and increase this number so it pulls in further the plastic and does not let anything to ooze, or you can bump up the speed of the retraction. Just don't change it significantly, okay? And you can turn on and off to retract when you are doing a layer change or anything, but here you have the control over the amount of retraction, the speed of the retraction, and so on, to avoid, as I said, this stringing problem. So this is the retraction area that I wanted to tell you. So that was under printer setting. Under filament, I guess I showed you the temperature area. I showed you the cooling of the fans. Under advanced, I'm not going to go over each and every one of the options, okay, because there are a ton and you can talk about them until tomorrow. I really want to limit it to the area that are the most useful to you. So under print setting, I guess I have covered all of this. Here you can turn this on or off to detect whether there is a bridging or not, okay? And remember, I explained the bridging for you too. Bridging means to print an overhang without having support material, just by moving fast enough and controlling the amount of flow, and really it can do a good job if the size of the overhang or the bridge is small. The bigger the bridge becomes, the longer the overhang becomes, the bigger chance you have for the material to sag under its own weight, because nothing from beneath, no support is basically bearing its weight. Okay, so if you want to activate bridging, right, you can turn this guy on or off. And that's for bridging. For infill, I guess I have said anything. You also have here a control over bridging angle. So here it's 0, means if it goes even perfectly horizontal, you still can do bridging. If you don't want the bridging to start unless the angle of the overhang is a specific angle other than 0 degrees, right? So for example, you want, let's say, that it only does a bridge if the overhang is something like this, not flat. So this is 0 degrees, right? This is like, for example, 15 degrees. So if you want to only do bridges when the angle is different than 0, then you can change that angle. And the default is, well, I'm going to do it regardless of the angle. I want to go with 0 angle. Then I guess I mentioned this, support material. I guess I mentioned the important stuff. The speed, I guess I mentioned. This is again the motion for a bridge, how fast you want to move, right? For acceleration of it, and this is the speed for motion in the bridge, right? So you can control those. As I said, I don't have any multiple extruder here, so I should be good on that. Then under advanced, this is the place that you can basically control the flow rate, right? And you clearly see it says, but it's just for bridging, not in general. This is the flow rate of bridging compared to a normal flow rate. So it says do not use as much plastic and push out as much plastic during bridging as a normal print, right? If you use 100% flow rate in a normal print, when doing bridging, just use 95%. And then there is something here called the elephant foot, and that means basically when you have the plastic being printed, the bottom layers under the weight of the top layers, they start to deform a little bit. Okay, so if you have, let's say, a column like this and you are printing it, especially if the material is hollow and you don't have a ton of support, infill and any draft angle, then these bottom layers under the weight of the top layers, they might start to deform. So your end product might look something like this a little bit, because the bottom layers are basically squeezed down. And your print looks something like this, then we call this the elephant foot. Okay? One of the things you can do is you give yourself to the bottom of your part some draft angle to compensate for the elephant foot. And we're going to talk about it in future videos. But here, one of the items that it is trying to compensate is elephant foot compensation. And you see it says the first layer will be shrunk a little bit. So what it does, it's not going to print the first layer as much as it is supposed to. It is going to print the first layer a little bit smaller. So when the load of the top layers come in and the first layer is basically squeezed down and it's a little bit extended, it becomes what? The right size that you expected. So the compensation here is by shrinking down the first layer a little bit. And that's the phenomenon of elephant foot. Okay, so I guess I mentioned almost everything that you need to know under the print setting. Oh yeah, I just forgot one thing, the flow rate. I forgot that. So you go back to filament setting, and under the filament setting, if you click on the filament, there is one factor here called extrusion multiplier. And this is the way to change the flow rate. So right now it's 1, means 100%. And you can change it to 90%, 110 by changing it to 0.9, 1.1, and so on. So if you want to change the flow rate, you can change this, what we call extrusion multiplier, under filament setting, under filament. Okay, so that's how you change the flow rate as well. So hopefully now I told you most of the important stuff that you need to know about the print setting and filament setting of Prusa. What else? And I told you about bridging and retraction. The only other things that come to my mind at the moment is one, slicing a part and just printing a portion of it. So if I choose this part and then I go to cut, this bottom option, and then it allows me to cut, and then I can keep the upper part or the lower part. So it allows me to cut at a specific Z value, right? Let's say here the Z value is almost at the neck, and then I only want to keep the upper part, right? And then perform the cut. There we go. Right, so now it is only going to print what? From that portion, right? And this is very good if the CAD models that you brought in are not what you want to print entirely, you just want a portion of it. is really saving a lot of material and print time. And let me tell you another interesting thing. So we brought this snowman, we scale it down up, we can do whatever we want to it, we can even cut it. And now that we did all of this and got a modified STL file, right? So when I get this, right, now I have the good option of what? Exporting this guy as STL. I can say, hey, export this as STL, and let me just put it under download and call it Snowman 1. Right? So now look, if I get rid of this and go and bring that Snowman 1 here, you see? So that's very important, because now you can use Prusa Slicer for what? For STL file manipulation. Now it might have some error, you have to fix it. But that's the big advantage. You can bring an STL file, and remember, this software is free. So now you can easily use this software for STL or mesh file manipulations. You bring a file, and without using any advanced mesh file software, you bring it in, go here and say, well, maybe I want to make this taller. Like that, right? Or maybe I want to slice it a little bit. So bring that guy down, maybe from here, keep the upper part like this, perform a cut, and then what? Right click on this guy and then export it as STL. So you see, I can easily generate different STL files without using any sophisticated software for that, right? Look here. Good. So do not underestimate what you can do with this software. You can do STL file manipulations. And there is one thing here under configuration. It's called Flash Printer Firmware. We're going to talk about this later when we get to hardware setup and everything. So I'll show you when we get to the hardware, and I'll show you the physical 3D printer and how to work with it and everything. I'll also come here and show you how to connect the USB wire and to the computer and to your printer, and then do a firmware update. Okay, but basically what you have here, you go, and before you're coming here, you should have already downloaded the firmware from Prusa website, and then you browse for it, you get it, and then if you connect the USB cable to your computer and the other end of it to the printer, then you click on Flash, and guess what? It is going to update the firmware for you just like that. So we are going to get to this Flash Printer firmware later on for you. And if you want to download the firmware, just type in Google Prusa firmware update download, and then it takes you to Prusa website, one of these two. Then you can download the firmware for the appropriate printer, right? So this is for almost all of these printers. This is the latest version. As I said, that's all you need. Download that zip folder, then go back, and then here I go to configuration, Flash Printer firmware, browse for that, change this hex file to all files, go to that zip folder, select it, and now, as I said, if I connect my printer to the computer using that USB cable and click on Flash, it is going to get my firmware updated. The last topic is if you want to print with more than one color, when you don't have that multi-material head extension. Let's say you want to print something like this. This is what I printed for alphabet learning. So you see the base of it is in orange color, and then the letters are printed in white. Can I do that? Yes, as long as you are not changing the color of the spool or the filament within one layer. If you want to chop your total print into several sub parts or sub prints, each one with a separate color of the spool, you can do that easily inside the Prusa software. But just what you need is when it gets to the point that you need to go to the next color, the machine starts beeping and telling you that, hey, come and change the filament. I'm waiting for you to come and change the filament. And if you do and change the filament, now it is going to start using the new color. And so you get your 2, 3, or several color basically part. But again, the color within each layer is going to stay constant. And you have to manually change that filament, right? Because it doesn't have that multi-material head extension. How would you do that? Let me show you this last one. So here I'm going to bring that for you. Let's say here, right? And now I want to print this. So if I say slice, you see it is going to do the slice, and all of the layers will be literally just one color, unless I bring this down to where I want the color to change. So I bring this slider down right at the bottom of these letters. Okay, you see here, you go up to when you get to the first layer of those letters. So you see when you go from 14 to 15, that's where those letters start to print. So I go to the beginning of 15 where I want to use a different color now, and then I click on this plus. And now if you look, it broke down my total bar into 2 separate categories with 2 different colors. So now if I go up, look. Now if you can see clearly, it is showing 2 different colors, right? And if I change this to something else, maybe a little bit more familiar, then you can see it much better. So now you clearly see that it has broken down my print into 2 sub prints, the orange plastic and let's say the red plastic. Now whatever color you use with your spool doesn't matter, but when it finishes layer 14 and wants to start layer 15, then it stops the print, beeps to get your attention to change the spool, and then resume the print using the new color. And that's exactly, as I said, how I got this part. So printing with more than one color when you don't have the multi-material head extension. This is, I assume, the last topic I wanted to talk about. So I told you most of the important stuff that you need to know, and I hope that it was useful to you. So I will see you in my future videos about the physical printer. I'll show you the hardware. I'll show you the setting of it, how to work with it, how to troubleshoot problems during the print, and so on. But I wanted you to first know how to work with the Slicer software. So thank you so much for staying with me for this long video, and I will see you in my next video. Thanks.